live when they can, so they can participate in the interactive, but we know that sometimes schedules don't work out, and teachers have really come to rely on having things recorded so they can either go back and look at them later or access them later. So we are going to record this session. And Eric, I'll turn it over to you to introduce our team today.
Great. Well, welcome everyone. We may have some more folks joining in shortly, so we'll sort of do a soft start here. I'm Eric Havel. I also work with the Community Resources for Science as an environmental educator. And this is part of a three-part program series that we're running this fall. We kicked off our environmental and climate literacy series with a big teacher resource fair in mid-September. And so I know some of you may have joined us for that. Historically, we would have partnered with Chabot Space and Science Center and done that on site, but this year, given COVID, we pivoted to a digital experience, and it was well received, had a great time. And then we, the second part of our series is this series of workshops. And so you're immersed in that right now. There's 10 workshops that we're offering for the fall. And Tracy Ostrom has graciously supported us with offering this workshop this morning, and I'll formally introduce her in just a moment. And then the third part of our series program is the creation of some potential professional learning communities, PLCs, around various topics of interest to all of you. So, you know, just kind of keeping in mind, if you do join us for other workshops during the fall, they're all no cost. They happen on Thursday afternoons or Saturday mornings. Keep in mind things that you'd like to continue exploring, because that's going to help us define and inform the learning communities that we'd like to create. So that's a little bit sort of amorphous right now, but we're working on developing those out. And we'd be very excited to hear your thoughts on that, where you could use additional support. And, you know, think everything from big picture to small picture, like topics you want to cover, maybe focused on environment or climate, maybe digital learning, maybe inclusionary kind of topics, access and accessibility of programs, thinking about different cultural standpoints and viewpoints. We're really trying to immerse that into our programming as well. So with that, I'd like to introduce also Betsy Mitchell is on the CRS team, and she's joining us this morning as well. Also works at the UC Department of Paleontology. And I'm gonna kick it over to Tracy as our host for the workshop this morning. Tracy Ostrom is a longtime colleague of ours and has done some great work with Globe. So Tracy, thanks again for supporting us this morning.
It's all good. Thanks, Eric. And thank you, Teresa, for inviting me here today. I will do a disclaimer right now that we will be in high gear in the next hour or so with the presentation, and I just wanted to let you know that while we'll be going quickly, we have a lot of information to cover and provide you today. And feel free, time out, stop, repeat, whatever it is. Teresa and Eric are going to monitor the chat for us so that we make sure we don't lose anybody along the way as best as possible. And this is also going to be an interactive opportunity for all of us to participate and share and discuss and question together. So I really invite you to be a part of the interaction as we go through the program. I say probably the best thing to do right now is just to get started. So as Eric said, my name is Tracy Ostrom, and I'm with UC Berkeley Department of Chemistry. I'm a former high school environmental science, chemistry, biology teacher. I taught for about 17 years, and as a teacher, I implemented this program called Globe, which is a hands-on environmental education program with my students, both in chemistry, biology, and AP environmental science. And so I was very passionate about giving students a really hands-on experience and opportunity to do science, not just learn science. So firm believer in this opportunity to get kids kind of relating what's going on in their communities to what we're learning in the classroom. So that's my passion for the Globe program was born as a teacher, and I was lucky enough to continue providing support to teachers, which is what I do right now in the West Coast here in California, Hawaii, New Mexico and Nevada as well. So I am a part of a program that's funded by NASA, and GLOBE is also a NASA-funded program. The program that we are working in is called GLOBE Mission Earth, and it's a consortium of universities across the country that are doing very similar work to what I just described I'm doing, and that is teacher support for implementing GLOBE in the classroom. And just one more message here. We've had to rethink our program because as I opened up and I said GLOBE is a hands-on field science program, it's really hard to do hands-on field science through a computer. So we really rethought our focus, our direction, our goals for this school year, and spent a lot of time over the summer focusing on this idea of data literacy and getting students continue to be passionate about science and learning, especially, the whole aspect of STEM learning, but in the context of data literacy. So that's really the focus today, is to talk to you about GLOBE, talk to you about the GLOBE Observer app, and specifically as it relates to data literacy. So I say, let's get started here. So first thing I like to do is to offer a poll. And our poll question is, what do you think data literacy refers to? So let's launch this poll here and see how we do. So go ahead and hopefully everybody can see this poll. And go ahead and just put down your thoughts. This is a multiple choice question. So if you think it refers to more than one thing, feel free to do so. So we got some responses going on here. Let's see. Good. Got about half the folks responding. All right. So it looks like everybody here is put in at least one response. So I'm going to end the poll and let's share the results. So this is what we all think data literacy refers to. About 75% of you put both collecting and organizing data. 92%, just about everybody, said visualizing and analyzing data. Everybody said interpreting data. And about 75% said sharing data. So this is great. This tells me a lot about you guys as teachers and our audience. And so keep these ideas in mind. Keep in mind as we move through here. I'm not going to tell. There's no wrong answer here, but you'll see as we move through the presentation what we're talking about in terms of data literacy. So here we go. Today we're going to talk about what is data literacy. Why are we talking about data literacy, especially in the time of distance learning? We'll talk a little about careers and culture and data-driven skills. And then I'm going to end up by giving you like a 1, 2, 3 step how of data literacy with your K-12 students, including looking through a lens of distance learning and how we can do this with our students through distance learning. So let's start with the what and why. So this quote is from Kristen Hunter-Thompson. She has a website called DataSpire. And by the way, I'm sorry, I should have said this earlier. The PowerPoint presentation, all of the activities and lessons that I'll be sharing with you today will all be available to you through the CRS website. So if you miss something today, including the recording, if you miss something along the way, feel free to access after the webinar. We'll get all that stuff up there so you guys can access it and maybe even use it with your own students. So the what. So here we go. The ability to collect, organize, visualize, analyze, interpret, and share data, not just for yourself, but for others to use and for others to understand. This definition comes from Kristen Hunter-Thompson, DataSpire. She's also a guest lecturer at Rutgers University. She is my go-to in terms of data literacy. So you'll see her presence throughout this webinar today. So I want you to focus on those words in blue, and you might have seen these words before in maybe a poll you just took. So in that poll itself, all those pieces were components of data literacy. And when we talk to our students and we work with our students about data literacy, it could be any one of these components: the collection of data, the organization of our data, how we see the data, turning numbers into visuals, how we interpret the data and analyze the data. That can be a little tricky for students, and certainly the sharing of the data. And I'm going to tell you about some opportunities how your students can share what they're doing with other students and with scientists through the GLOBE program. Okay, so why do we care? Why do we care about data literacy? Well, the hook for why we care is really in the societal situation that we're in right now. We're doing distance learning. We're a lot of our decision making, our policies, our practices right now, even politics, are driven by data. If you just look at a Facebook, if anybody's on social media, you know, data is used to drive ads, to drive shopping. Data is used to track where we are with our devices. And so our society is really built around data. And we don't really, it's not upfront in our faces. It's kind of a behind the scenes thing. But certainly the fact that we have mandates on masks or shelter in place or social distancing, those are all very real data-driven practices that we're in right now. And so that's the hook on data literacy. And that's why, you know, seizing the moment that we're in right now of distance learning is really an opportunity for us to show students how data drives our situation, where we're at. So let's go to the next one. This is a little bit about culture and careers. And this is something, as a high school teacher, I was really passionate about connecting what we're doing in the classroom to what their next steps are after high school. And it's never too early to start this idea. Elementary school, middle school, high school, to start giving students the opportunity to think about why we as professionals are passionate about learning what's going on in our classrooms. So these are just some of the careers, and honestly, I can't think of a career that doesn't have any kind of data thinking involved with that. But one thing, you know, we're in a census year, so you can bring in the concept of what does the data from a census tell us? What do population, and this is something that's related to climate literacy, you know, what does increased population or decreased population do on resources? That's all data-driven information. So culture and careers is very, very much connected to data literacy. Here's Kristen. I want to tie in the standards side of what we're doing. If you look at the next generation science standards, and I know all districts and states are in different aspects of adoption, or they've adopted it with their own flair to it. But if you just look at the science and engineering practices of data literacy, you'll see that it's really sprinkled with the concepts and ideas of data literacy, from looking at analytical data, interpreting the data, using graphic displays of data. And so this is a little summary of Kristen's take on the NGSS connection with science and engineering and data. All right, so she mentioned the collection of cloud cover and temperature. Those are all, she's referring to GLOBE protocols, and GLOBE protocols are practices that students can do. in order to collect data, in order to understand what's going on out there. So I'll talk a little bit about those protocols in just a minute, but that's what she's referring to in those classroom practices, and even through distance learning, those practices that can occur.
Tracy, just sorry to interrupt. I think that audio I'm not sure if got that. 'Cause I get a couple pings in chat and I couldn't hear it either.
Okay, how about this?
Data has a really important role in science as well. And here I've highlighted the different components across all 8 of the science and engineering practices in the next generation science standards that we've incorporated that we've adopted to be our science standards in New Jersey, as well as many other states across the country. And so while sometimes we think about data as just analyzing and interpreting data, data in fact plays a huge role in everything that we do when we're doing science. And we can see that in lesson plans, where there's more and more lesson plans are on the market that incorporate real world data or have students collect their own data, just like you all are doing with the information that you're collecting about the cloud cover and the temperatures and things like that.
How was that? Were you able to hear it that time?
I think that was good. Yep.
Okay, so sorry about that. Thank you, Eric, for letting me know that.
Sure.
Probably we're going, what is she talking about? Okay, so again, the connection with data and science and engineering practices is that it's interwoven into our NGSS, our next generation science standards, in terms of science and engineering practices and how students learn about science. And a couple things she mentioned about clouds and air temperature were globe protocols. So I want to talk a little bit more about that right now. So on the left, you see those data literacy skills: collect, organize, visualize, analyze, interpret, and share. And 3 of those components of data literacy, visual, analyze, and interpret, are what I'm going to focus on today. But collection and organization of data, these are really connected quite well to the globe protocols. So when we collect data, we can do so as a teacher, we'd go outside, we'd have these tools, we'd collect data, we'd bring it back, we'd enter the data into these data sheets, and then we'd upload it onto the Globe website. So our school would have a set of data that we worked with. Really hard to do when your students are at distance learning, but I have a solution. There's something called the Globe Observer app, and I'm going to show you that website a little bit later on in the presentation. But the Globe Observer app is simply an app on your phone that students can use to collect data and enter it automatically through a Wi-Fi connection. And I know there's definitely students out there that have challenges with Wi-Fi, but they also can put it on a data sheet and collect it on a data sheet as well. So the Globe Observer app is this mobile app. It's a free download. All it takes is an email address to get on to the Globe Observer app. It's in Google Play and the apps in the Apple Store as well. The organization of data is how we document what the data is. The graphs and visualization of data come from looking at numbers and putting them into some kind of visual. And this is where the students start to struggle a little bit. And so we're going to do an activity in a little bit that kind of helps us understand data visualization. But it's really all about taking those numbers and putting it into visuals. The analysis of data is, what do we see? What do we see in that data? Are there peaks? Are there valleys? Is there a data point that is like kind of a wackadoodle data point? What do we do with all this data? What is the story that the data is telling us? And then the interpretation of data is kind of going full circle, going back to that research question and saying, what are the data telling me in order to answer that research question? Where are we at with that data? And then finally, there's an opportunity for students to share what they've learned, and that is through something called SRS and IVSS. So let me explain what those acronyms mean. And SRS is a student research symposium. And it will be virtual in 2021. So any student who's got internet access, or a group of students, can present their research, where they go through, here's my research question, here's my investigation of what I did, and maybe I cultivated data online, maybe I collected data myself, and then here's the analysis of my data, and here's what we found out, here's our conclusion. So there are student research symposiums throughout the country, whether it's the Southwest region, which is that New Mexico region. The Pacific region is Hawaii, Nevada, and California. We have our own research symposium. And then the International Virtual Science Symposium. GLOBE is a program that's an international program. So there's over 30,000 schools from around the world that are participating in GLOBE, which seems like a weird number to kind of get my head around. But this is where students upload their research project into the GLOBE website, and they get reviewed by scientists from around the world that provide comments and information to them. So it's really kind of a nice way to dialogue, as opposed to, it's not a science fair, but it's a way that students can talk about their research and why they did their research. Okay, so let's start with a question. If you guys could help us out by seeing what our answers are in the chat. So right now what I gave you a little bit of information of what data literacy is. And perhaps right now you're kind of thinking about your own practice, your own, maybe a content area, an age group that you are teaching, maybe a method or methods that you're teaching with your students, whether it's you're in a virtual situation or a hybrid situation or in-person situation. Think about what you're doing right now with your students and ask yourself, how can I support my teaching by incorporating data literacy, or what do I do now that is connected to data literacy? And you didn't really think about it as a connection with data literacy. So let's just take a couple minutes and go through, if you could enter your ideas or your responses into the chat, and then we'll share those out.
Hey Tracy, this is Nate. We Mescalera, we hosted the SRS, Southwest SRS a couple years back, and we also been to 2 SRSs as student. I've taken my students to them as well. So
right.
We won we won all 3 students brought home awards from the 3 that we attended. So
awesome.
It is really worth attending, and all of my students in my classes have downloaded Globe Observer.
Oh, good. Yeah. That's a nice way for them to, especially at the high school level and middle school level. Most kids have access to a smartphone. Maybe not so much with elementary kids, but certainly their parents may have access to a smartphone or some sort of device where they can tap into the Globe Observer app. Does anybody else want to share in the chat maybe some practices that are connected to data literacy? We see here about data sheets and charts are a nice start. I work with a 2nd grade teacher in elementary, and there was a really simple bar graph on that she showed me. She goes, "Is this data literacy?" And I'm like, "Yes." And it was a bar graph that was in their textbook, their online textbook. And I was like, oh, this is perfect. Just taking that bar graph and showing it to students and asking them, what do you see in this? And they'll say, oh, I see colors. Great. Looking for patterns is an awesome way to teach data literacy skills. And that's a part of the interpretation piece, right? What kind of patterns do you see, and what are these patterns telling you? Taking measurements. graphing. Any kind of graphing exercise that you do with your students is a great way to get them thinking about numbers and visuals, making that connection between numbers and visuals. Showrevealgraphs.com. Teresa, did you want to talk a little bit about that?
I've been talking with a number of elementary teachers who've been exploring this resource and experimenting with it. And they've really said that it's really helped to have some, especially with this distance learning, some really interesting conversations with their students about data visualization, looking at a graph and then gradually adding a little bit more information as they talk through what this graph might be telling them. And so I have only learned about this source in the last month. So I have in my own notes to spend a little bit more time exploring it. But it sounds like it's been something that particularly upper elementary grade teachers have really found useful. And I believe also high school and middle school teachers use it as well. So potential resource to check out.
Awesome, thank you. And I see Megan here, you have an APES class and you do a lot of data literacy work with them, which is, I think Globe and APES, that was my nice little hand in glove fit with my students. And showing them not just biodiversity information, but also resources, right? You know, with ecosystem resources is also a great way to look at data in the classroom with AP students. So great, okay. Well, good, these are all some great ideas. And I hope if you didn't get a chance to write something down, just kind of continual thinking along those lines in terms of data literacy in your content area, because really what we're trying to do here is support your work. So anything that we can do to help support your work, that's a win-win. So let's move on a little bit. What I want to do is to get kind of down into some real important information, connecting of some resources to connect for you. So we talked about data acquisition, either through the collection of data or you can also go through portals. And My NASA Data is a great data portal from NASA. The Earth System Data Explorer has a tutorial on it. And if you just Google My NASA Data, you'll get it. There's all sorts of lessons and mini lessons that are Google Classroom ready. If any of you are using Google Classroom, that you can import into your own classroom. One thing that we've started here is student toolkits. And a toolkit is basically something that we're actually giving to our students to use during this distance learning time. Really simple opportunities to do some data collection. We have 3 different toolkits: atmosphere, hydrosphere, and biosphere. And this is part of the Globe Mission Earth program, where we offer these toolkits to our teachers who then on lunch pickup day or materials pickup drop-off day, they can pick up their toolkits and just have an opportunity to do some hands-on data exploration on their own. And then I want to show you this app that both Nate and I referred to. This is the Globe Observer app, and it's very easy to get to, globeobserver.gov, and it really tells you all about the different types of data collections that are available through the app. You can do a cloud observation. You could do a mosquito habitat observation, like where in this area would mosquitoes tend to breed. That might be something really important for areas that are along the coast or get lots of rain. There's also a land cover app that you can do within the Globe Observer, and you can take land cover measurements and identify the type of land cover it is. There's a tree height measurement, which is really kind of a fun thing to do. It doesn't have to be trees, it could be flagpoles, but again, this could involve some math. Not a lot of math, we're just talking about distance from where you're at to the tree. So those are all resources that are available through the Globe Observer app. And I mentioned the My NASA Data portal. I'll also put a plug in for the Beacon website on UC Berkeley Department of Chemistry, Atmospheric Sciences. They have some up-to-date data on the nodes that they have around. A node is basically it looks like about the size of a shoebox. and it's an air quality measurement device. So it's taking all sorts of air quality data. And there's some really great graphs about air quality and shelter in place information. So as we go through the process of data literacy, some of you have already said this before, but I'll just reiterate it. Let students create some visualizations. Give them an opportunity to do some graphing. Give them an opportunity to talk to one another about what they see in a graph. If you provide them a graph, give them just some, you know, table talk time or breakout room time, which you guys are going to have in just a second. Give them some sort of opportunity to interpret what the graph might be saying or what the map might be saying. We're going to have, I'm going to show you an activity that you can do because you guys are going to do that activity today. And then giving them that opportunity to share what it is that they see and they do, have them ask questions. That's a part of that opportunity with the Student Research Symposium. Okay, so let's go ahead and giving you, and again, this is in our, this will be in the you can access any of these data portals from the PowerPoint presentation. But there's so many data portals out there for you guys that you can use that gives you some really great visuals on data. So these are all links. So when you get the PowerPoint, you can go right to them. Okay, let's go a little bit deeper dive into data visualization. I don't know if you've ever heard of a graph choice chart, but a graph choice chart is a great way to start talking about data visualization. Like I said before, when we visualize data, we're taking the numbers and making it into a picture or a visual that students can better understand or better analyze. So when we choose our visual, there's certain criteria that we just say, oh, you know, let's just all do line graphs for everything. Well, a line graph doesn't necessarily represent the data as well as a bar graph or a pie chart or a distribution graph, etc. So what we have to ask when we do data visualization is, what question are we answering? When we know what question we're answering, it helps us to decide what kind of visual that we have. And then how are we going to communicate with that visual? So let me give you some examples of data visualizations. We're just talking about visualization right now. So there's 3 different types of graphs in general. There's a comparison graph. So you might recognize a bar chart as a comparison. Maybe a before or after or change over time between 2 or more groups. A distribution graph looks at what's the variation in a group. From what time to what time do we see? A box plot is a good example of a visualization that shows variation of a group. And then finally, our composition. It's kind of like that part of whole. So a pie chart is a good example if you wanted to do percentages of data. So those are the 3 main types. They're composition, distribution, and a comparison. Those are the 3 main types of visualization. So now what we're going to do, Eric, we're going to put people into breakout rooms, okay? And so what I want you to do, and I'm going to go to the, where's my PowerPoint? Oops, let me go out. Let me do this. So we're going to go to, oops, of course. Get back here. All right, so this is what you guys are going to do. If you're in breakout room 1, and you're going to take a look at these various types of graphs here, ways of presenting data. So they're all out here along the edge. And what you're going to do is you're going to take this and you're going to decide, is this a composition, sorry, a comparison, a distribution, or a composition graph. And you're just going to drag and drop as many of these different types of graphs as you can. Breakout room 2, you're going to do the same thing. You've got your own graph. You're going to do, just drop and drag. And the same thing with breakout room 3 and 4, depending on how many breakout rooms we have. So I'm gonna pause here and see if anybody has any questions as to what you're gonna be doing in your breakout room. All right, so what I'm gonna do then is I'm gonna put in the chat the link. And so when you're in your breakout room, just go ahead and go to the chat either before or after you get in your breakout room. And the link is in there. And let's do, I don't know, how about 3 or 4 minutes at our breakout room?
Great, and just logistics for the breakout room. We have 3 participants in the elementary breakout room, plus Teresa and Betsy from the CRS team. We have 2 participants in the middle school room, room 2, and I'll be jumping in on that probably. And then we have 5 participants in the high school room. And I don't know, Tracy, if you pop in and out, maybe starting with the high school.
Yeah, I will. Oh, Christine, are you having a problem accessing the document?
Yeah, so am I. It's asking for permission.
Oh, goodness gracious. All right. I apologize. Thanks for letting me know. Oof.
Right, Christine, you win the prize for fastest typer.
Yeah, no kidding. I'm not quite sure how to get it so everybody can get in there without typing in everybody's email address, which would be quite cumbersome.
Isn't there an option for open access?
Can you change the settings to anyone with the link?
I went into settings and it didn't give me that opportunity.
Oh, technology.
I know. I'm so sorry,
Under
everybody.
the blue share button, Tracy.
Yeah, I clicked on that. It wasn't wasn't very friendly. I'm gonna go old school here and actually go back to the source. And
In the meantime, while Tracy's doing that, I will suggest there is a great article this week that was in the Wall Street Journal that was really a powerful, I thought, example of data visualization. And I was trying to I was going to share the link with you, but the version, I'm going to have to search for it. It was really showing about COVID spread across the United States and how it was probably really established here in January. And it's a very strong, just data visualization example with something very real and that we're all living and experiencing. So when I find a shareable version of that, I will include that in the email afterwards. But you can probably find other really great examples. The New York Times is doing a lot of really great work with data visualization. So I would, the online version, so I would encourage you to look for those kinds of examples just like in the news, in the popular press, because you're seeing more and more journalists using data to tell stories.
You know, also in globe.gov, you can set up a your own school as a site, and your students can enter data from around your school. One of the things we did, we had the kids select sites around the school and collect data. Like once a week, we'll go outside and take pictures of the sky and send that to NASA, and NASA will send them pictures back from the satellite looking down, and they're looking up. It's pretty cool, and you can go back in time 2 or 3 years back and see what type of weather it was during that time, like last year this time. What was the weather like? So it's a pretty cool site.
Oh, that's awesome to know.
Yeah.
You having any success, Tracy? Somebody put some suggestions, but
I'm actually, I can't see what the suggestions are, but feel free to shout it out. I am.
Deborah has suggested that you can go in your Google Drive in the document,
Yes.
On the share option, right click on the document and select the share option.
Yes, I am
Under
doing.
advanced, on the share setting window, you should be able to click change link. On link sharing window, select public in the web option.
Oh, Deb.
Is that sounding like a pathway that's open?
Yeah, I just pulled it up. So I'm in the share. I'm so sorry, you guys. Yeah. A couple people are in it. I noticed.
We've all been there, you know.
So settings, here we go. Oh guys, just it's just
So right click on the document and select share option. Click advanced button. This is exactly, Megan points out, this is how virtual school is going for teachers.
no kidding. Right? No kidding. All right. It's not letting me, I can't find the advanced side of it. So, and I just don't know why, but it's just not there. So we're going to switch, and I have a feeling this is going to be the same for those other activities that I have planned. So you know what? We're a small enough group. Let's just go ahead and do this as a team. So okay. I'm going to go ahead and share my screen again and go back to our presentation. And then I'm just going to go to the document itself. So here we are. Okay, well, a couple people have access to it, but let's go ahead and just do this as a team. Can you guys see my screen okay? Is that a yes? I can't see you guys.
You can make you can make the graph part, the screen part bigger by putting your cursor on the divider between the people's images and the screen share and moving that arrow to the right, and it'll enlarge the screen.
Individual attendees can do that.
For attendees, yeah, if you want to have a bigger view of the slide.
Okay. All right. Well, this is as big as I can get it at this point in time.
Yeah, no, that's good. The attendees themselves can adjust what they see.
Can adjust it, yeah.
Mm-hmm.
Okay.
Good.
So we have lots of different graphs around here. Sorry, this is probably taking longer than we had time for, but we have lots of different graphs around here. So let's just do a few of them in the interest of time. So I'm going to take and identify any graph here, and you guys can just do a shout out because I can't see the chat right now, but maybe if you just want to put it in the chat, Eric can help us out here. Yep. And the types of graphs that you think might be a choice for a comparison graph. So a comparison is going to be a before or after. It's choosing two things. Anybody have any ideas here from what you see that would be a good example of a comparison?
Maybe a bar chart.
Okay.
And Deborah shared a line chart.
One in the upper right-hand corner.
Great. Okay.
Compare chart.
Scatter chart.
The scatter chart. Here's another. Different kinds of line chart. Okay. How about a distribution? So we're looking at change over time, something that might be show spreads.
Box plot.
Box plot, yeah.
Okay. Awesome.
Histogram.
Histogram. Good. Okay. And let's just jump down to composition. What would be a good composition chart?
Oh, Deborah added bubble chart to
Bubble chart. To what?
to the distribution.
Okie doke. Bubble chart. Yep. That's a good one.
Oh, how interesting.
Composition.
I'm going to add one down here. Most people don't pick this one. This is, I'd never heard of this chart until I did this activity myself, this chloral path, which is kind of like a distribution.
Yeah.
So how about composition pie chart?
Pie chart.
Yeah.
What
Anybody
about
else?
the stacked area chart?
It's stacked, yeah.
Yeah, okay. That would be good. All right, so just giving us a little bit of feel for what kind of choice there are in the different types of graphs. And this is a good activity. There's actually an elementary version of this activity, a middle school version, and a high school version. And what I'm showing you here is, you know, kind of like the whole kit and caboodle. But, and there's actually an undergraduate version of this activity as well. So when all is said and done, if you look at every single chart that's on there, you might be able to kind of arrange them in this type of order here, right? So this is an activity on the dataspire.org website, and this will be a part of what you can connect to, and you can download and use this with your students either online or in person with them. And again, like I said, there's different levels of this activity. And so I just wanted to end up by saying that also use your resources online, and for something that's maybe at the high school level, you can use a quite involved graph choice chart to help guide students in deciding the types of visuals that are appropriate for the data and the question that they're answering. And so now let's just jump into storytelling, and that's what I like to summarize. When I talk to my students, when I was asking them to you know, analyze data, I was asking them to, what kind of story is the data telling us? And so we have to be careful when we analyze data, because often, just this past spring, I was working with students who had collected data in the fall, and there was a really weird data point, right? And they said, oh, well, we just need to throw that out because that doesn't make sense. And often if we clean data, and that's why I use that cleansing of data in italics, we have to be careful because that could be a very important data point. And I always relate the story of Antarctica and the ozone discovery, because NASA had data outliers in their program that that threw out data points from Antarctica. And in actuality, those were the true data points of ozone levels, which led to the Montreal Protocol, et cetera. So the main purpose of data analysis is really to find the meaning of our data. And so in Globe, we have some sentence starters for students to help them analyze their data. So these are just some sentence starters that you can use with your students as well. Again, this is all available to you. And so instead of you going into breakout rooms, let's just do this again as a team. And we're going to now take a look at an image. And what I'd like you to do is take a look at this image here. And in the chat chat room, write down an analysis statement. So remember, analysis is telling a story. So take a look at the picture here. This is a NASA satellite image of a region in China, the Wuhan region of China. And in pink, what we're seeing here is the concentration of NO2 levels. And so this visual here is in 2019. And it's in February, March of 2019, and this is February, March of 2020. So what story do you think this visual is telling you? So go ahead, and again, once you have correct access to this, you can use this activity with your students, and they can actually write, through a text box, they can just write right on here. The story, is about blah, 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 blah. So go ahead in the chat, go ahead in the chat and let's talk about what kind of stories you think it might be, we might be able to tell with this particular visual.
All right, and Laura, we've got some questions. Let's see.
Can you, I can't really understand what the pink areas are showing because I can't read the legend.
So sure, sorry. So the darker the pink, the higher the NO2 concentrations, Marsha.
NO2 is a pollutant?
Yes, nitrogen dioxide. So this is often found in car exhaust, factory, off gas. It's a leading contribution to climate greenhouse gases.
And Laura's suggesting a rationale, or a reason behind this is that the pollution levels are lower because people stopped traveling due to COVID.
Yeah, I'm wondering if the data is mislabeled because the byline is the same at the top. Pollution levels in China are markedly lower than last year.
Yes. So yes. So good point. Thank you for pointing that out. This is a graph that I actually split into two, and it was actually one graph. And so in a PowerPoint, I would show this one first.
Oh, I see. So Tracy, what's happening is I can't actually read the 2019.
So this is 2019.
Yeah, so I thought that was 2020 on the left because that's a number I can see.
Sorry. Yes, this is,
so, okay,
you can't see it. It's not a very good graph, and thanks for pointing that out, that in terms of a visual for students, they use the color, which is similar to this 2019, and they really should have used, a blue or a green or, some other color, right? So this is the 2019 pink versus the 2020 pink, you could say. Okay.
Sorry.
So we had an interesting statement that was, I'm sorry, could you read that one again, Eric, that you just read?
Yeah. So the interpretation from Laura, pollution levels are lower because people have stopped traveling because of COVID. And then there was a few more follow-ups. Joshua, as the area shut down, work and travel, the pollution dropped. And then Alicia, the story is about the change in pollution levels over a year. It seems to be telling us that the NO2 concentrations were lower in 2020 than 2019.
All right. So these are all, thank you all for writing some ideas down here. So here's what as a teacher, here's what I would point out. We have to be careful between interpretation and analysis, okay? So nowhere in this graph do we say that there was shelter in place. Nowhere in the graph do we say people stopped traveling, right? That's an interpretation that you made based on your inference, based on prior knowledge. When we analyze the graph, all we're allowed to do is what is the story that the picture is telling us? So in this case, the picture is telling us simply that in the Wuhan region, because we don't even know what these other regions are where there's no data, right? Is it because there's no data or there's no pollution? We don't know, right? But all we can say is in the Wuhan region of China, NO2 levels dropped from one year to the next. We don't even have a data to know if this is a significant drop or not, right? Because our legend here is just doing a dark color versus a light color pink, right? So we have to be careful in making our analysis a simple look at a simple statement about what we see, not why we see it. And I hope that makes sense to everybody. It's a very common challenge for students to just simply write what they see. And that's why we need lots of practice. So here's another one. So go ahead. Does anyone want to comment or anything? Okay, well, let's do this one. Let's do it again. So here we what is the story? What's the story here? So we have daily COVID-19 cases by region. And this is February 1st to July 1st. And as you can see, the regions are spelt out. So let's write in the chat what we think the story is on this particular graph. And Eric, if you just want to shout out what some folks wrote, I'll put it down here for discussion.
Sure, you bet. So I think folks are still processing, so nothing yet.
Perfect, perfect.
All right, Teresa is jumping in. Maybe overall, there's a steady increase in cases, but in some areas, such as the green area, the number of daily cases has actually decreased after going up earlier. And then we have Marcia sharing, this is sheer numbers, not cases per 100,000 question mark. So
correct.
If this is total numbers. Yeah.
Mm-hmm.
Okay. And then Megan, on average, daily COVID cases are increasing from April to July.
Okay.
Yeah, another one confirming an interpretation that daily cases are increasing.
Awesome. Okay. So great job, everybody. So what we're seeing in this is, again, we're analyzing the data, and you did a great job at not interpreting the data, but we're analyzing the data to simply tell a story. And the story that we see here is that you would say COVID cases are increasing around the world, with exceptions in certain regions. Or we can say that from this date to this date, we see an increase in COVID cases.
And Tracy, one more nuance that folks are catching on, that the Americas in particular have a very highly, an increasing amount of COVID cases, April through July. And that contrast to that, Europe, question mark, maybe Europe's cases overall were actually starting to decrease over time.
Excellent. So I love that. Great job, you guys, because these last two statements are more focusing on a specific region, and that's okay to do that as well. So we can look at the big picture, but we also can look at smaller pictures within this story and tell a story about America, if we wanted to do a comparison, the Americas versus European area. So that's perfect. Excellent. Good job.
Tracy, to that one too, this is an interesting one. Just looking at the America curve, that there's an oscillation, like the graph is even toggling up and down, you know, periodically within, let's say, a week span type of thing.
Yeah, yeah. So that's interesting too. It's an interesting point to bring out in this story. And it would actually lead to questions. Why is there a fluctuation of COVID cases apparently weekly kind of stuff? Does it have to do with testing rounds, or we can and say due to lack of test availability, we see that because we don't know what the test availability is here. So that might be an interpretation. But I love the fact that we can point out that there's a story here that the data fluctuates week to week for the Americas specifically. So that's another story. So there's lots of stories that can be told by this graph. And I think bringing those examples out with students helps them to feel comfortable, like, oh yeah, I saw that too. I just didn't know that I could say that. So good job. Okay, I am noticing the time here. So I'm gonna keep moving on here. And we just did a little share out on those two graphs. So let's do interpretation. So before I said it's really hard for students to kind of define the differences between analysis and interpretation. So that's why I like to tell students analysis is all about telling a story about what you see, and interpretation is relating that story to your question. Okay, what's the meaning of that data? What's the meaning of the information that you've just analyzed? And so we're going to go back to these ideas of sentence starters and giving students opportunities to, and I'm going to give them to you because I want you to, try to think of using these sentence starters, because I'm going to go back to these exact same graphs now that we had before. And if you could look at these two pictures now, again, we're in China and the NO2 levels. What would be the interpretation of this data? We analyzed the data and said between this year and that year, there's an increase of NO2 in 2019 compared to 2020. But what would be the interpretation that you might put, a spin that you put on this? So you can even in your interpretation ask a question. What kind of question does this data answer? So let's do this. Let's in the chat room write a question that you think the data are answering in these pictures. What question? What kind of questions do you think someone looking at these two pictures might be able to answer?
There's a few coming in the chat.
Okay.
What changed between these two time periods?
Okay. What was the change between 2019 and 2020 in the Wuhan region, right, in terms of NO2? Great. And
maybe a more broad question, how have pollution levels in China changed?
How do pollution levels in China change, or did they change? I hate to do a yes/no question, but that's a great kind of supporting question. Perfect.
And sort of a kind of getting into a little more detail, what specific changes in human activity and in natural activity such as volcanic or seismic might have happened?
Might have happened. Okay. Yeah. So sometimes looking at visuals leads us to ask questions that maybe the visual doesn't answer, but is our next steps in our research project. Awesome. Okay, let's go to the COVID visual. What kind of question do you think this particular graph might be answering? What kind of research question do you think this one might be answering?
Okay,
Any good questions in there?
yeah, I'll start with a,
Okay,
a
go for it.
broader one.
Uh-huh.
How much testing is being done in a region?
Right. That's a good question. Yeah, I don't know. I don't know if this graph is indicative, but we might use this graph to help us tell that story of testing availability. Great.
Here's a couple more comparing different regions. So we have one, comparatively, it looks like Africa has fewer cases. Is this due to lack of testing, better public health? And then alternatively, we had, why do the Americas have more significant drops and rises compared to the other regions?
All right.
Again, looking at the Americas, how have confirmed COVID cases changed from February to July in the Americas?
Great. Okay. Well, good. I think you guys are getting the hang of this and being able to discern between an analysis statement and interpretation statement or question. So good job. All right. So the only thing I would shout out on this one is that make sure that when we're interpreting data, we're interpreting it in terms of whatever question we might have answered, or sorry, might have asked. Okay, so let's go ahead.
Can I ask a question? So there's kind of a difference between looking at a graph to sort of look for a pattern, and then also versus setting up a research question and then using the data to address that specific question, right? So you might do both of those with students, correct?
Correct, right.
Is there a different way you might approach that, or would you basically use the same tools and the same kind of framework?
You know, it would be dependent upon my age group, to be honest with you. So I might keep it super simple with, an elementary age group, but just like, what do you see and what do you think it's saying? So when I do tell a story with data analysis, one thing I would ask my students is like, well, who are the characters in this story, right? So if we take this particular graph that we're looking at, I would say the characters might be, oh, well, there's an Americas character and there's a Europe character, etc., right? And how are the characters behaving in this story, right? And that might be something a little bit simpler for students to get. And then my interpretation question would be, what are the characters doing? Like what happened to the characters in this story, right? So if my question was, what was Europe's COVID cases between this time and this time, that might be a question. So I'm asking how the character behaved during that time. So try to use analogies like that, I think, for different grade levels. I think in an AP Environmental Science class, we can kind of get into the nitty gritty and ask them to look at those specific patterns. And do a statistical analysis based on, given data. But I think, you have to choose based on the grade level.
And Tracy, if I can just jump in for a second, I would say for the elementary level, I think it's so important, in particular, but at all levels, even when you see, again, in the popular press, there tends to be a habit of non-scientists of combining the two steps that you just had us go through, that interpretation of the data, just what does analyzing the data in terms of what do we see, what are the numbers, just let's make sense of what we see here, and then the step of try to interpret it, and that kind of gets smushed together. And for scientists, and it's a chance for teachers to really emphasize how scientists think about things and use evidence to support claims, that it's really important to separate out those steps and to make the time, which again in elementary is very difficult because there's such a compressed amount of time for science. So I think having that for educators in their minds of these distinct steps, and they can really call out what they're asking students to do at each step, is really important. So I appreciate the way you broke this out.
Awesome. Okay. Thank you, Teresa. All right. So let's move on and go to the how-to. We don't have a whole lot of time left, but let's go through this because I think it's important, like where do we go from here kind of stuff. So consider this. right? When we talk about data literacy, it is a process. It is not a one lesson, good, I'm done. I'll do a lesson on data analysis, a lesson on interpretation, blah, I'm good. So consider it as a process and consider it as a learning progression. I'll say that in a few minutes. Also consider incorporating, especially for the middle school and high school grade levels, consider using data literacy outside of the science class, even if you refer to it or give a graph example, whether it's politics, looking at blue states, red states. I mentioned the census, using it for math, mean, mode, percent, fraction, all that kind of stuff. And English is a great opportunity to talk about data literacy because it's an argument, and that's a part of the English standards, is to look at how to write an argument and how to support your argument with data. So and finally, looking at your social sciences, and I think we've said enough about connecting data literacy to culture and politics, etc. There's a great opportunity or an entry point to do that in other science classrooms. In terms of visualization, step 2, really make sure you focus on the question, not on the numbers. What question are we trying to answer, and who are we trying to answer this question for? Who are our audiences? So that's really important with graph choice and data visualization in general. And then finally, data literacy, as I said, is a learning progression. So if you're at the elementary school level, the recommendation is, just stick to some really simple line plots or pictographs or pie charts and bars. The middle school level, you can build off of that and incorporate maybe a box plot or a dot plot, something like that. And then in the high school level, you want to build off of what they may have learned, we hope, in the elementary and the middle school level, and get a little bit more involved with the type of maybe a little bit more distribution types of graphs, like bubble charts or stacked area charts, etc. So remember, it's a learning progression, lots of practice, lots of opportunities for learning. This will be in the PowerPoint, all sorts of online resources and ready-made lessons for you to use for data literacy. And this will be for you guys to take a look at. And I wanted to share a recommendation. It's just a suggestion. So how do we know where our students are at with data literacy? Can't necessarily assume they know a whole lot. So we've created these data literacy warm-ups. So in a warm-up, we just give it to them, and you can do it online. You can do it if you're in person. And you give them a graph, and you can use any one of the graphs that we've already seen. But I'm going to show you what this data literacy warm-up looks like. And basically, and again, you'll have access to this, you're showing them a graph and you're simply asking them one question. And there's lots of different types of graphs that you can choose from, or if you want to relate a graph to your own, specifically to a content area that you have, here are some really simple graphs looking at glacial melt over 100 years. Here's a pie chart, maybe for the smaller grade levels. And you're simply going to ask them one question. And that is, what are the variables, if they know what that term means? What are the characters, if you want to say it that way, in your story, and in your graph, and what's the story that's being told? So that's a data literacy warm-up. There's also another warm-up. It's the exact same graph, but this time it's interpretation. And I used a Google form for our students to do this in a warm-up. So and you'll have access to this Google form as well. So in this Google form, we're giving them a picture. And what's nice about a Google form is that they can simply fill out the form, and then I can get all of the responses in a spreadsheet, and then I can give them a quote-unquote grade. And the grade is simply a check. Yep, they got it. They know what's going on, or X, woo, way off, or maybe a question mark, I'm not quite sure. And then what I've asked the teachers to do is give me your responses so we can do a little temperature take. But really for teachers, it's a bit, and you guys don't have to give me your responses, but it's a way in which it will inform your instruction, your teaching practices. Oh, awesome. So this is the last slide. So next steps is to think about how data literacy warm-ups or other teaching techniques or methods may be appropriate for your students. And I guess we've got a couple minutes here. If there's any questions, I'm happy to answer any questions or any comments from any of the information presented today. We're happy to share those comments or questions with all of you.
And I think folks can unmute if you have questions, because we're a small enough group that we probably don't even have to do it through chat.
Thanks, Eric.
Tracy, I'll ask you while people might be thinking of a question. Do you have a suggestion of where to start? If someone wanted to get started with the Globe resources, and maybe for each grade level, sort of like what's a good way to begin dipping your toe in the water? What would you suggest to do first?
Great. So the first thing in terms of Globe, Globe does a great job at data collection and data organization, those first two pieces of data literacy. And in order to get started with Globe in that way, all you need to do is have a school email address. And I'm going to share my screen real quick here. This is the Globe website. And if you're not familiar with the Globe website, it's just globe.gov. And you can just click on Getting Started. And you can join Globe. It's free. All the resources in Globe are free. You just identify yourself as a teacher and you fill in all of the information that they're asking you to fill in. It's super, super easy to get started. And then once you're a member of Globe, you can do a training, and there's online training. And so an online training is basically you do this overall Globe training, but then you pick an area of interest, whether it's atmosphere, biosphere, hydrosphere, pedosphere, and you do a training in the area you are most interested in. And each training consists of a number of slides, PowerPoint slides, and then there's usually about 5 or 6 questions at the end of those slides. And once you've answered those questions, and you've answered them a certain percentage correctly, then you are trained in Globe, and you can begin to enter data into the Globe database. Only teachers who are trained in Globe and a member of the Globe community can actually enter data in there. So it's super easy to get started, and I'm happy to facilitate any interest that you might have in being a Globe member, or even joining the Globe community here with our partnership, the Globe partnership at West Ed, UC Berkeley.
One of my little pet peeves is about labeling on graphs. And working with 7th graders, that's something we have to work really hard on when we're having them make graphs of data that they've gathered, and figuring out what should go on what axis. So
yes,
there's a lot of pieces that they have to put together in order to make a graph that shows the information that they want to show.
Absolutely. Yep.
It really seems very challenging for them.
Well, and I think showing them a graph that you think has those components, those pieces put together, and having them identify what is it that you see here. Oh, you see some words on the left-hand side. What do you suppose those words on the left are referring to? You see some numbers on the bottom. What are those referring to? And I think giving them some sample visuals are great ways to get started in that data literacy piece. Good point.
I also notice when I'm listening to scientists give seminars, a lot of times they do not go over their axes. They do not give very good information on what is in a graph. And that's a real pet peeve of mine. And it's really easy to forget to do because it's obvious to you, but it's not always obvious to students.
Right, exactly. As a matter of fact, we were working with some UC Berkeley graduate students on looking at that data comparison with air quality and shelter in place. And they had the title of the graph, you know, PM 2.5, et cetera, and there were numbers on the left-hand side, but there was no axis identified. It's like, could you please put in what these numbers on the left-hand side mean? So, yeah. So I think there's a couple questions in the chat about resources and where to find this, Teresa. So I'm going to be giving CRS the PowerPoint, the recording, the documents itself, all these documents that I've shared with you that you couldn't get before, but we'll be able to get now. And we'll get those to CRS this weekend. And then Teresa, about what time would they be able to get an email to let them know that they're available for them?
So it should be on Monday, but you'll get an email when Corinne is back. She has a weekend off, and when she comes back on Monday, she'll send out an email that has the links and all the follow-up information, and as well we will post them, and I put in the chat the resource page, so you'll also, if you bookmark that, you'll be able to go back and find the resources from this workshop and any of the workshops in our whole series, so going back to the ones that have already happened, and you can also see the signups for the upcoming workshops. And for those of you who are hoping to earn the unit of CEU of academic credit, that's a total of 10 hours. We're tracking for people, those who want to earn the credit. So just reach out to Corinne about that if you have any questions. But you can combine any of these sessions to earn that credit. And we'll be sure to follow up with and share all that information out. And I know we're almost coming up on time. I was wondering, Tracy, kind of following up on Betsy's question, if somebody else doesn't have a question to throw out, you're thinking in terms of the difference between having students engage with physically drawing, paper and pencil, their data charts or their data visualizations, their graphs, versus using some of these computer programs to do it, whether it's an Excel file or some other tool, where sometimes there might be a little bit of a disconnect between, they just put some numbers in something and pushed a button. If you've had any experience, any thoughts about the value of like physically drawing out data tables before putting them in a digital version?
Oh, absolutely. And that's kind of the philosophy of the GLOBE program, is getting students doing science, which is why I highly recommend having an opportunity for students to collect their own data, even if it's just pen and paper kind of collection, like, oh, I think that there's, no clouds in the sky today, big circle, right? It's something as simple as that, where they take cloud measurements, percent measurements, 3 times a day, morning, noon, and afternoon. That's 3 pieces of data that they can use for their own analysis and visual analysis and interpretation. So I'm a firm believer of doing science. And so the other part of that is ownership, right? So when students are collecting data for their own purpose, for their own learning, that is so much more meaningful for them rather than just giving a data table, right? Showing a data table. So in the time of digital learning, I would pick something super simple like that. Just like, let's look at how many clouds are out today, right? And then have some sort of Google sheet where everybody could put what they think their data measurement is for that day, and then go from there.
And maybe just referencing sort of the next steps that Teresa was sharing with us and sort of beyond. We're about halfway through the workshop series. So we've had about 5 or 6 of the 10 that we have planned for the fall. And as Tracy mentioned, this data analysis and interpretation is really a process, an iterative process. So if this is something that resonates with you, and you would like to build your own capacity to use more data and bring it to your students, it would be a great thing to infuse into a PLC. So wherever the PLC decides it wants to go, whether it have an umbrella topic of climate or overall, maybe it's about data interpretation, claims and evidence, data and interpretation. So just be thinking if this would be a component that you would like some help with and some support with, say moving on from November as we sort of think about these more, clustering ourselves into learning communities.
Great. Well, as a part of the information that will be shared with all of you, my contact information will be on those documents. So feel free at any point in time to shout out, give me an email, and I'd be happy to work with you in any capacity that makes sense for you. So I think that's about it.
Awesome. Well, Tracy, this was so informative, and I just love the chance to get in and explore the Globe resources a little bit more. And we're excited to share this out with teachers and then hear back how people are using them. And so
wonderful.
Please share with us as you use them and you discover something. Please, we like to build that sense of community. So keep us posted, and we will share out your tips and suggestions. So I hope you all have a chance to go out and enjoy a lovely Saturday. And thank you so much for presenting this session, Tracy. And
well, thanks for being here, everybody. It's definitely, the more we can provide information and support to all of you in this really challenging time, I think the better off our students and our communities will be. So I appreciate all the hard work you guys are doing. I know it's challenging. I've been there, done that, but it's so much bigger now. So thank you so much for hanging in there and wanting to learn more and improve your own practices.
Great. Thanks. And I think, Tracy, I don't know if you're available to hang out for a minute or two if people have individual questions, but otherwise that will officially end our session. So thank you.
Oh yeah, happy to.
I have a question before I leave.
Sure. Yeah.
I'm Irene.